Hi guys, welcome back to the channel. This is Ajit. So we are going to be solving today's state code question, which is even odd tree. So we are given a binary tree named even odd tree if it meets the following condition. We can say this particular binary tree as even odd if it meets these particular conditions. That is, the root of the binary tree at the level index 0 and its children is going to be level at the index 1, and then the children at the level is going to be index 2. What does it mean is, like suppose let's say we have a binary tree and this is the root, and then whatever the children which are present, this is going to be at index 0, and then their children it is going to be at level index 1, and then the children of this particular children is going to be level or index 2. So this is what they are saying. And then again, for every even indexed level, all the nodes at that particular level have odd integers. That means, let's say index 0. As index 0 is even index level, all the all the nodes which are present at that particular level should be like odd integers. And then whatever the level, like let's say this is the even index, let's say this is the previous node, and then there is one more node which is like next to that, and then this should be increasing order. Let's say this is 1 and then this should be 2, and then let's say if it is odd index, that means index level 1, then all the nodes which are present at that particular level is going to be even. That means if it is index 1, then the integers value must be even, and then they should be strictly decreasing. That means if it is 10, and then the other should be 8, like it should be decreasing in the order from left to right. And given a root of binary, we need to return if it is possible that all these particular condition is satisfied. Suppose let's look at the one of the examples so that we can get the clarity, like how we should be looking into the question. So if we look at this particular question, this is the level equal to 0. For this particular level, as it is already given that this is the even index, so all the integers which are all the values of the nodes should be odd. If it is even index, then all should be odd, and then this should be even, and then this should be odd, and then this should be even. And what about increasing or decreasing? Suppose if it is even, then it should be strictly increasing. That means always the next node should be increasing for this particular case, and then for level 1 it should be decreasing, and then for this particular case it should be increasing, and then for this particular case it should be decreasing. So these are the conditions we need to check uh, for the for the particular tree, so that we can return whether it is possible for this particular binary to become even or odd. So let's look at the question. This is one, okay. Other nodes are not present and it is odd. So this is fine. And then we'll move to the next level, which is level 1. At this particular case, as it is level 1, the numbers which is present at this particular level should be even. So this is even and this is even. And then this should be strictly decreasing. That means this should be like 10 should be greater than 4. And then we'll move to the next level, and then we'll pick 3, and then uh, all the all the nodes which are present at this particular level should be odd. So it is true, and then we'll say 3 is less than 7, and then 7 is less than 9. So this is strictly increasing, and then we'll move to the next level, which is this particular level, and then this all the integers which are present at this particular level is going to be even, and then this is strictly decreasing. So so it satisfied all the condition which are given in the particular question. So we can say that this particular binary is going to be even odd. And then, yeah, for this particular case is going to be even odd. So we'll be looking at the next example so that we'll see when it is going to fail. So we'll move to the next example. Suppose let's say this is the level. The level 0 should contain odd values, and then this is odd, this is even, and then this is going to be odd, and then this should be increasing, and then this should be decreasing, and then this should be increasing. So let's say this particular node is odd, okay, and then whether it is increasing or not, as there is only one node, we can say that this is increasing. And then we'll consider this particular level. For this particular level, all the nodes which are present is even. Yeah, that is true. And then it should be decreasing. Yes, it is decreasing. Okay, fine. And then we'll move to the next level. At this particular level, we can say that it is less than or equal to. It is equal. It is becoming equal. And then this is it. This, as we can say that this is not strictly increasing. This is increasing only. So it should be strictly increasing. As it is equal, then we can say it is not a valid even odd. So we are going to return false. So we need to write a solution so that it will satisfy all the condition. If it doesn't satisfy at any particular case, then we are going to return a false. So let's try to take the example. Let's say we'll start with the root node. We'll start with the root node by putting the root node in the queue, which is going to be 5 right now. So we'll take this particular root node and then we'll keep in the uh, queue. Whenever we are traversing from level 0 to level 1 and level 2, we need to traverse all the nodes which are present at that particular level. Let's say we want to traverse this particular level. That means we need to get all the nodes which are present at this particular level. So we are going to get that via taking size of the particular queue. Suppose let's say size of this queue is 1, and then we'll traverse till this particular count becomes 0. That means we'll try to decrease the size. We'll try to decrease the size by doing size minus minus, and then whenever this becomes 0, then we can stop at that particular level, and then we'll move to the next level. So at this particular level, we'll pick the 5 node, and then we'll remove the 5, and then at this particular case, we'll check left and then right. At this particular level, we'll check the whether this satisfies the even odd condition or whether it is increasing or decreasing based upon our conditions which are required. Suppose let's say the even level is even, then we can say that this particular number should be odd. Suppose let's say even the value is even. Suppose let's say the value is even. Suppose if the value is even, then this should not be the this should not be our correct solution. So we are going to return false at this particular level. And then one more thing we need to take care is, suppose let's say this should be increasing. Suppose let's say this should be increasing in the sense previous should be less than the next current node. But if the previous value is greater than or equal to current, then we are going to say this is false. At this particular case also, we are going to return false. And then, is there any other conditions we need to check? No. As of now, there is no. If the level is even, then we are going to check this particular condition. If the level is odd, suppose let's say level is odd, At that particular case, all the numbers should be uh, even, but if the value is odd, for odd it should the value should be even, but if the value is odd, then we are going to say this is not the correct case for this particular binary tree to become even odd. So we are going to return false for this. And then if the previous value, this should be the odd level indexes should be decreasing. That means previous should be greater than the current. But if it is less than or equal to current, then we are going to say this is not the correct solution for this. This is not the case which we want. So we are going to return false for this particular case. These are the conditions we are going to check whether this particular level is correct or not, or the value is correct or not. If it doesn't satisfy any of the condition, we are going to, if it satisfies these conditions, then we are going to return false. And then we'll move to the next thing, that is traversing of the nodes. Suppose let's say I took I took the node 5. At this particular case, I took the node 5. 5 can contain two values, which is left, that is 4, and then it can contain 2, which is right. So if the 5 has the left node, then we are going to put inside the queue. And then if it contains the right node, then we are going to put inside the queue. And then we'll pop the 5. So whenever we move to the next iteration, which is level 2, we are going to take all this size, which is going to be q dot size, and then we are going to traverse for this particular case. Suppose let's say we'll move to the next iteration, which is going to contain only 4 and then 2. At that particular case, we are going to have only 4 and 2 in the queue, 4 and 2 in the queue, and then we'll pick the 4 value. We are going to pick the 4, and then we are going to check the particular conditions which we had explained earlier. So we are going to pick 4, and then we'll check whether 4 contains left or right. So it contains left, so we are going to pass it into the queue. So it will contain 3, and then it contains right as well, so we are going to add it to the queue. And then again we'll remove this particular 4, and then again we'll move to the 2, and then again we'll remove 2, and then we'll add 7 here. And then after traversing 4 and 2, by knowing the size of uh, q size equal to 2, we are going to stop at this particular case, and then we'll move again to this particular level, which is going to be 337, and this is equal to this. So we are going to say this is not correct, so we are going to return false. So that is the intuition. We are going to do the same thing in the code. So let's look at the code. Yeah, we are just traversing by level, and then if it doesn't satisfy any of the condition, then we are going to return false for that particular case. Yeah, let's see the function. This function is going to give whether it is even odd tree or not. So we are going to store the tree node in same level nodes. This is going to store all the nodes which are present at that particular same level. So at the starting, we are going to start with the root, and then level is going to be 0 at this particular case. And then we need to store the node value which is present at the particular case. Let's say this is the node. So what is the previous node value, so that we can compare whether it is increasing or decreasing. So for this particular case, we are going to take previous node value, which will store the previous node value whatever present. So for traversing the same level nodes, we need to get the number of nodes present at this particular time, so that we can traverse all the nodes which are present at the same level. So we'll take the number of nodes equal to same level nodes dot size, and then again we are going to we are going we are going to assign the previous node value based upon whether the level is odd or not. Suppose let's say the level is even, then we can say that it should be increasing. Increasing in the sense the left should be less than the right. The left value should be less than the right, or previous value should be less than the next or current value. So we are going to assign it to int minimum. Suppose let's say if the level is odd, that means it should be decreasing. It should be decreasing in the sense previous should be greater than the current. That means we are going to assign int maximum so that this will be greater than the current. So we are assigning the default value so that it will not face uh, any errors or any errors. And then we are going to decrease the number of nodes which are present at this particular level, and then we are going to pick each node from the queue, and then we are going to pop at the same time so that it will be removed from the queue. And then these are the conditions which we had focused previously. If it is even, then we can say that it should be increasing. But if it is decreasing, that means previous node value is greater than or equal to current node value, then it is not a correct solution. So we are going to return false. And even should have odd elements, but even level has the even value nodes, then we are going to say this is not the correct condition, so we are going to return false. So, and then we are going to check if the level is odd. If the level is odd, we are going to check whether this particular case is decreasing. That means previous value should be greater than the current value, but it is reverse of that. So we are going to return false, and then it should be odd should contain the even integers. If it contains the same odd integers, then we are going to say it is a false. So we are returning false. And then for this particular current node, there will be two nodes which are present at the next level. So that is going to be left node and then right node. So if it contains the left node, then we are going to push into the queue. And then if it contains the right node, then we are going to push into the queue. And then let's say we'll traverse from one node to the next node. Then we need to store the previous node value right now so that for the next node it is going to be the previous node for that particular case. So we are going to say previous node value equal to current node value. And then after completion of all the nodes which has been uh, checked, and then which has been updated to which has taken all the children nodes, then we are going to say level plus plus so that it will move to the next level. And then we are going to check until all the level nodes has been traversed. At last we are going to return true. Why? Because all the conditions has been satisfied for all the nodes, so we are going to return true. If we come to the time complexity is going to be big of n, and then space complexity is going to be big of w. Why? Because the time complexity is going to be big of n. Why? Because we are going to traverse all the nodes which are present in the particular binary tree. And then for the space complexity, it is big of w. Why? Because it is going to it is going to store the nodes which are present at the particular level. Suppose at this particular level, it is going to store 5. At this particular level, it is going to store 4 and 2, and then at this 3, 3, and then 7. So it is going to store the number of nodes which are present at that particular level. Suppose if we take that as w, then it is going to be big of w. Yeah, thanks for watching the video. If you like the video, and if you haven't subscribed, please subscribe to the channel. Thanks. Bye.